I want to walk through the issue of resizing a canvas so that it fits with the world space. There are a number of issues that occur when you do this, and it helps to be aware of them. I've just created this project and set the region for a Nexus 4 device. This isn't necessary, but it helps to have some context. I created a couple of textures that I imported here. One is just a green rectangle the size of a Nexus screen, which is 1280 by 768. And the other is a small 100 pixel by 100 pixel red square. Now if you look at one of the textures, you can see that the inspector shows that the pixels per unit is set to 100. It's important to note that the game space is measured in units, whereas the canvas space is measured in pixels. So let's see what this means. First, I'll set the green rectangle as the background. I'll do this by creating a sprite and dragging the texture into the sprite texture area. You can see the background does not cover the entire area, and this is due to the camera size. So let me just resize that camera to the appropriate size. This way the background fills the entire area. And again, I'm just doing this for context. It's not really that important. Now let's take a look at that sprite. I'll add the rect transform, which will give us some dimensions so that we can see what's going on. Notice that the width and height are essentially at 12.8 and 7.68. This is because the game area is set in units. And remember that we saw a texture was essentially 100 pixels per unit. So our 1280 pixel by 768 pixel rectangle shows up as 12.8 by 7.68. These are in units. So this is really important to note. Let me add a game element to the screen, and I'm doing this all in 2D space here, so I'm just going to create another 2D sprite that will fill with the texture of the 100 by 100 square pixel. So this square sprite fills up a particular area that represents our 100 by 100 area. Once again, I'll add the rect transform and take a look at the width and height. Here again, they are 1 by 1. So far so good. Each element is represented by units rather than pixels. So let's add our UI element. And as part of Unity requirements, a UI element must reside inside a canvas. So if you try to create a UI element without a canvas, Unity will automatically generate a canvas for you. And you can see here that the canvas appears to be much larger than our 1280 by 768 background. This is because our canvas is measured in pixels, not units. If we do any raycasting to a UI element, we must resize the canvas so it fits in our game region. Otherwise, no raycast collisions can be detected. To modify our canvas, we must change the render mode in the canvas area to world space. This doesn't change the size of the canvas, instead it simply allows us to control the size. Now we need to scale down our canvas appropriately. So if my canvas has a size of 1280 by 768, I can scale down the canvas so that the region occupied would only be 1/100th of the current size. In other words, if I scale down the x and y values to 0.01, that essentially means my 1280 by 768 is resized down to 12.8 by 7.68. Now let's add a UI image to this using the same 100 by 100 texture. Take a look at the image here. Notice the height and width is 100 by 100. So all that has happened is our canvas is scaling down everything inside of it. So in effect, our 100 by 100 pixel object is fitting into that 1 by 1 unit region that we see in our game area. Okay, let's add a collider around each red box so we can detect when collisions occur. Now notice that my collider here has a size of 1 by 1, so this is for the UI element. We need to change this so it actually matches the region that we have, which is 100 by 100. Then adding the collider to the sprite is not a problem. It'll automatically find the region that we need. Then let's create a simple script that will tell us the size of the object that is detected. First, we need to set up a raycast, and again this is all in 2D. So I'm going to create our physics2d.raycast, and it needs a point of origin. So I'm going to use the mouse position as our point of origin. We'll also need a direction, which is going to be our 0 direction, which is directly towards our objects. And remember, we have to make this all in world coordinates from the camera's perspective. Next, we can check if the ray hit any object. That is, if it hit any of our colliders. So here I'm just going to check if our collider equals some value and write out some information to the screen. If a hit occurred, we'll find the size of our objects. Now let's run our project, and we can see here that when we mouse over our UI image, we receive a value of 100 by 100, whereas if we mouse over our game image, we receive a value of 1 by 1. So this is an important difference that we need to make when we're measuring or resizing values from the UI canvas.